this video, I'm going to teach you about density. So the definition of density is the amount of mass per volume for a given substance. So on the screen, you see three different substances of greater and greater density. The box represents a given volume. So we are going to keep the volume the same for all three substances. The blue circles are going to represent the mass. The box all the way to the left has only 4 units of mass per that given volume. The next box has 8 per that given volume, and the last one has, I'm not even going to count that, okay? So the box all the way to the left, since it has the least amount of mass per that given volume, that substance is the least dense. As you add more and more mass into that same volume, that substance starts to get more and more dense. Okay, so the more mass per volume that a substance has, the more dense it's going to be. Now we can calculate density, which is great because density is a physical property of matter. So if you have some sort of an unknown substance, if you are able to find the mass and volume of that substance, you can calculate its density and then figure out what that substance actually is. Okay, so the equation for density is mass divided by volume, but I like to put equations into triangles to help students if maybe you're not so good at manipulating equations. This really seems to help. So the way the triangle works is you cover up the unknown variable that you're trying to find out through the calculation with your hand. And whatever is left will tell you the calculation that you need to do in order to get the unknown. Now, a couple things before I show you how it works is this horizontal line here represents division, and the vertical line here represents multiplication, okay? So let's say that we're given a problem and we need to calculate the density of something, and we were given the mass and the volume. To figure out what to do with the mass and the volume to calculate density, you would cover up the density with your hand. So D represents density, M represents mass, and V represents volume. So you cover up the D with your hand because that's density, that's our unknown, and we're left with M. This line represents division, so M divided by V. So you would just divide mass and volume and you would get your density. Now let's say instead that you are being asked to calculate the volume of something and you were given the mass and the density of it. You would cover up the V with your hand because that's your unknown variable. Whatever's left tells you the equation. Mass divided by density will give you the volume. Lastly, if you were given a problem that asks you to calculate the mass of an object and you were given the density and the volume, you'd cover up the M with your hand because that's your unknown variable. You are left with density. This line represents multiplication, so density times volume will get you your mass. Okay, so that's the way that you use the triangle. You will see many triangles again in the future throughout the class. That's how they work. Now, to find the volume of various objects, there's a bunch of different ways that we can do this. So if we were given a liquid and we wanted to find the volume, obviously we would just put it into a graduated cylinder and measure it, okay? Now, the way that you properly measure the volume of a liquid, when you pour the liquid into a container, it's naturally going to form a meniscus, which is an inversion like this, due to the liquid being attracted to the sides of the graduated cylinder, pulling it upward. So because of this, graduated cylinders are specifically made to take that into account. So we just need to measure from the bottom of the meniscus, and that would be an accurate measurement, okay? The best way to measure at the bottom of the meniscus is to get down to eye level. Getting down to eye level ensures that you are getting as accurate of a reading as possible, okay? So this watermark would be This is 30, so this is 35. 36, about 36.5 milliliters. Okay, now if we were given a solid, the way to find the volume depends on whether the solid is a regular shape, like a cube or a sphere or a cylinder, or if it's an irregular shape, like just a blob of something. If the solid is a regular shape, we use math, right? You have all these equations that we can use to find the volume of that regular solid item. We're mostly going to be working with regular shapes that are either rectangular or cubic in nature. So you would just do length times width times height. I don't know that we're going to work with spheres or cylinders, but I would give you those equations if you were to need them. Most of the time, we're going to be working with solids that have an irregular shape. So in this picture on the screen, there's an egg, okay? That's an irregular shape. So therefore, we have to use something called the displacement method, or you might hear it as the water displacement method. Same thing. So all that you have to do is you take a graduate cylinder and you fill it up with water. Doesn't matter how much, just don't fill it up way to the top because the water level will increase. So we have a graduate cylinder filled to the 50-liter mark. The next step is to drop the irregular shaped object into the graduate cylinder, and then the water level is going to increase due to you dropping the object in. You take the reading after the object is in the water, so now it looks like the water level is at 150 liters. And then you just simply subtract the two. And the difference is going to be the volume of the solid that you dropped in. So 150, which was our final value, minus 50, which was our initial, gives us a volume for this egg of 100 liters. Now, the units for density depend on the state of matter. So if you are finding the density for a liquid, the unit for density is going to be grams per milliliter. If you're finding the density for a solid, it's going to be grams per cubic centimeter. You can use milliliters and cubic centimeters interchangeably because they technically equal each other. So if you see this box right here, in order to fill a 1 cubic centimeter box, which is a box that has a length, width, and height of 1 centimeter, it takes 1 milliliter of liquid. Therefore, a milliliter and a cubic centimeter are the same thing. So in the last slide, we found the volume of a solid in liters. We don't usually find the volume of a solid in liters, and we don't report the density of a solid in grams per liter. So we could convert the liters into milliliters and then just change it from milliliters to cubic centimeters because it's the same thing. So let's just do one quick example problem to make sure that you understand how to use the triangle. Let's say that we were given the volume of an object to be 25 cubic centimeters. We were also given the mass of that object to be 10 grams, and we need to find the density. So to figure out the equation to use, you cover up your unknown variable with your hand on the triangle. So we would cover up the density portion. Whatever's left tells you the equation. So we have mass divided by volume. So when we do mass of 10 grams divided by our volume of 25 cubic centimeters, we would get a density of 0.4 grams per cubic centimeter. And that's density.